Gosh dang it, I can't talk and play this game at the same time. Hi. Today we're going to talk a little bit about doing motion capture without motion capture equipment. So if you've been following this channel for a little while, you may recall that a while ago I did a tutorial about how to do mocap for VTube using only an iPhone. And today I think we're going to take that up a notch. We're going to add this little mouse in here. Part of what's so cool about this setup is that my mouse is tracking everything I'm doing right now. And on top of that, I'm not using any motion capture equipment. I'm just using the iPhone right now, and I'm just using my mouse. Now I'm just whipping my mouse around for no reason, but you get the idea. So that you can see the extra layer of interactivity that you have with the system. So if you're playing games with your stream and you're you're having fun and you're interacting with everything, you can actually get a really nice view of how your game is running. My FPS is maxing out here a little bit, but I'm going to show you how to do exactly this, how to build a mouse solver that will give you interactivity with your game streams. I'm just going to keep going for a minute. Just give me a second until we start the tutorial. You guys are patient, right? This is all going to start off with a mouse that you like. I made one in Blender. It's nothing special, but it gets the job done. If you wanted to, you could make it match your gamer mouse in real life, or you could give it RGB, or whatever the heck you crazy people want these days. Make it neon for all I care. Go ahead and pull your new best friend into the scene, and we are going to promote him into a blueprint. Go ahead and go to Harvest Components, and then make sure you select Actor. Go ahead and go to the event graph, and that's where we're going to be building all this functionality. We're going to be working inside the event tick node. Now, this is really expensive, and if you're wanting everything to run great with no frames per second issues, then you got to be careful with how many of these you use. I'm using a couple in my scene already, and we don't want to overdo it. Now, let's go ahead and add a new node. We're going to go get mouse position on platform. Now, it's really important to use on platform. This node is going to be able to give us basically the position of the mouse for anywhere on any of our displays. Come over here and we're going to build a print. We're going to need to get float values from it, so we're going to break vector 2D. Grab an append. We're going to add a little bit of space in between them just for clarity's sake. Now when we move our mouse around, we get this insane data stream. So you can see the numbers change based on where we are in space. So like here's my all the way to the x-axis, and here's my all the way to the y-axis, and even if I go off screen into some of my other monitors, it's still capturing. Alright, that's great. Now, we need to be able to compare this data to something to be able to get any sort of meaningful value that we can use to move the mouse around. I'm going to type in get viewport size, break it into a vector 2, and hook it back up to our print string. Now we can see the size of our viewport. This is probably the part of the show where I should apologize to you because I'm using a 4K monitor and you might be looking at this on a phone. I am deeply sorry. So now if we compare these two, we'll be able to get something interesting. Clear the append node. I'm going to make two sets of map range unclamped nodes. And I'm going to hook the x-axis up into the value and the y-axis into the other value, and I'm going to use in range B from the corresponding axes. I never figured that one out. Now for our out ranges, we're going to put -1 and 1. So now let's actually move the mouse. Set actor relative location. We'll create a make vector node, and then we'll import our x and y values here. And you'll notice that our mouse is completely gone. So what are we going to do with this? The reason for this is that the mouse is actually being set to 0, 0, 0 plus our -1 or our +1 in these two values. So that's not going to work. In order to achieve a proper relative value, we're going to have to parent the mouse to something else. So go up to create, go to all classes, and find an empty actor. Place it right on top of the mouse. Let's rename it so we don't get confused. Now we can parent our blueprint underneath the mouse holder. Now you'll notice this significantly changed our values. Let's zero them out. Now wherever the parent goes, the mouse goes too. Now you can see that the mouse is moving with us, just not very much. Let's up the strength on our ranges. 8 should do the trick. If you're getting incorrect rotation or bad input data and it feels like your mouse isn't oriented correctly, there's a couple things you can do here. Look at the rotations of the mouse holder, the mouse blueprint, and the static mesh component. For me, I was able to rotate my static mesh component 180 degrees, and this was able to fix my problem. And as a last resort, you can always go in and change the negation on your range. Changing the parent that's holding the mouse will change the entire axis that it moves on. So if you rotate that, you'll find that the mouse actually changes the way that it travels along the desk. Now that I've upped the strength on my range, and I've corrected all of the rotations, I have a mouse that works perfectly. So we now have a working mouse that moves in tandem with our real mouse. Amazing, but we need our character to animate and interact with it. Whatever we do next, we'll need to use an IK solver. An IK solver is computer logic, which basically tries to make the bones in a CG character look normal as they're deforming the skin. So let's say that you place your hand somewhere, the IK solver tries to figure out what's the most natural way to put the forearm and the upper arm in a way that will not look terrible. There's lots of ways to do IK solvers in Unreal. Control Rig has like 7. Animation Blueprint has a really simple one too, and that's where we'll start. If you watched the iPhone mocap video, and you probably should go back and watch that if you haven't already. In this video, we covered 2 bone IK nodes in Animation Blueprint, and we're gonna do the same thing here. If you watch that video, you'll see how we set things up with actors that could act as solvers for where the IKs should be placed. If you've done this previous tutorial, you've already set up IK nodes. In that case, you can just take one of those blueprints and you can just parent it onto the mouse, and then you're good to go. Here's a look at exactly what's going on in my animation blueprint. First, I have an event that begins when the level plays. It does a bunch of other stuff, and then it comes down and it grabs these 2 actors. First, it's grabbing our mouse blueprint, and then it's saving that data. Then it's grabbing another actor I set up as a physical point. Then every tick, the animation blueprint checks the mouse position and then converts it into a vector. That vector is saved and it can be accessed by the animation graph. And in this anim graph, we're using all of this information to be able to tell our 2-bone IK node where to go. On top of that, I also have these modify bone nodes. These are really helpful and very, very powerful. This one modifies the hand so that it's rotated correctly when it's on top of the mouse. You're gonna have to play around with this yourself in order to get this right. This one is set up to push my elbow down so that I don't just have a T-pose. This is a great stand-in if you don't have the time to make an animation asset. Make sure that you have your transforms set so that they're both adding to existing, but that your hand is being changed in world space, and your upper arm is being changed in bone space. I can't stress how important these settings are. You can see both the physical location of the mouse and the mouse elbow location are being used here to properly calibrate the 2-bone IK node. So this is mostly it. Here's our blueprints in totality. Ultimately, there's a lot more we could do with this thing, but I think this is fine for now.